Hello, physical science. Say this is our section 3. In this case, we are going to be classifying our chemical reactions. You do want to make sure you have the follow along notes open and ready. So there are follow along notes. If you do not have those, please go ahead and grab those while you're watching this video. So first thing, here's just a rundown of what our schedule looks like next week so you get an idea of what's happening each day. So we are going to have a lab on Wednesday. We'll have a reactions lab. Thursday is a review, and our test is in 2 parts just because we have the balancing equations, the reactions. There's a lot in this chapter. So that's going to be over Friday and Monday. We'll talk more about that next week. All right, goals for this particular lesson. First, we're going to identify the 5 general types of reactions, define oxidation and reduction, and predict which metal will replace other metals in a reaction. First off, there are 5 types of reaction. The first type of reaction is known as a combustion reaction. When you think of something that combusts, you think it's going to catch on fire and it's going to burn. So a combustion reaction is burning. We'll think things need to burn in the presence of air. In order for this reaction to occur, whatever the reactant is has to react with oxygen in order to actually burn. When it burns, it's going to create heat and light. Products that will always be present in a combustion reaction are always going to be carbon dioxide and water. This is your clue to figuring out, is it a combustion reaction? If the products are carbon dioxide and water, definitely a combustion reaction. I'll show you a couple of examples in just a few slides. Second type of reaction is a synthesis reaction. Anytime you synthesize something, the word synthesize itself means to make new. So our word synthesis, if we were to put this down, means to make new. If we were to make new things, we are of course going to form a new substance. In order to do so, we need things to put together, to combine, to give us that new thing that we're going to make. So here's some examples. First one, we have Ca plus O2 yields CaO. So is that a combustion or is that a synthesis? For this particular one, you're probably looking at this O2 going, oh, is that a combustion? She just said there was oxygen. But look at the product. Is there carbon dioxide and water? If not, then no, this is not a combustion. This is just a synthesis reaction. We're taking 2 things and combining them together to give me one. Next one. 2 things, combine it together to make one. This is also a synthesis reaction. Last one on here, I'm taking one thing, mixing it with oxygen, and making carbon dioxide and water. Ding, ding, ding! You are right! Yay! You are the winner of a combustion reaction! Yay! Little applause for you. All right, continuing on here. Third type of reaction we call a decomposition reaction. The word decomposition is made up of the parts decompose. What does it mean to decompose? It means to break down. Things here are going to be broken down into multiple parts. So we'll take one thing, break it down, and make 2 or more. To decompose something, you need heat. You need light. And you need electricity. You need one of those things. So if we were looking at this reaction as a chemical formula, all of those words would be the words that are above the arrows. So we would have the word heat above an arrow. We could have the word light above the arrow. And we could also have the word electricity above the arrow if we needed that as well. Our fourth type of reaction is a single displacement reaction. Think of the word displacement. We're going to displace something in the reaction or switch something around. So here, displacement, think of it as replaces. A single displacement reaction is when one element replaces another in a compound. So here we go again. We have, last one, we have number 5, the double displacement reaction. So instead of replacing one thing, we are replacing two things. So in a double displacement reaction, the positive ion of one compound replaces the positive ion in the other compound. The really good thing about positive ions is they're usually a metal. So the metal of one compound will switch places with the metal in the other compound. So we know a double displacement reaction has occurred if these three things are present. If there is a precipitate, what in the world is a precipitate? Well, a precipitate is a solid. So if there is an S after one of the compounds, we have a double displacement reaction. If we have made water, then we have a double displacement reaction, or if a gas has occurred, we have a double displacement reaction. So how do I know which type of reaction it is if I'm just looking at a formula? I have a very simple, easy summary to help you. First thing you always want to do is look at the reactants. Where do I find the reactants again? Oh yeah, okay. Those are the ones that are in front of my arrow. So it goes reactants over here, here's my arrow, there's my products. So I need to look at the things on this side. If there happens to be two elements, E here is standing for element, E plus an E is going to give me a synthesis reaction, an element plus an element. If I have a reactant that is just a compound, only a compound in front of that arrow, I'm going to have a decomposition reaction because this one compound has to break down into two or more things. Single replacement. Single replacement, I have one reactant as an element and I have one reactant as a compound. In this case, that element, that compound, makes it a single replacement. Double replacement then is I'll have a compound plus a compound. So when you go to identify these types of things, you want to sort of keep this summary in mind. So here's a couple of examples. Let's see how you do. So my first one here. And if you need to flip back a slide, remember you have your slides on the side. If you need to flip back a slide to see if it's an element, a compound, or two compounds together, what that reaction means, do so. So the first one, we have an element here, and we have a compound. Automatically, element and compound, we're probably going single replacement or single displacement. Second one, we have one compound that needs electricity to break that thing apart into two things. So here we get a decomposition. Next one, we have again one thing only. Hey, what did that little triangle right there mean? Heat. You're right. That meant heat. In this case, we have to add heat to break that thing down. So this again is a decomposition reaction. Whoops, sorry. Next one, we have a compound and we have a compound. Two compounds. This is going to be the double displacement. The next one, I have one element and one compound. This is my single displacement. Finally, I have a compound and a compound. Double displacement it is. Awesome job. All right. Last thing then, the type of reaction we have to talk about is known as an oxidation-reduction reaction. So first of all, during every reaction, elements have to gain electrons and some have to lose electrons to become more stable. This is why we drew our dot diagrams before. So if you remember, we had sodium that had 1 dot, chlorine that had 7 dots. Remember doing this? All right, so those are the 7. Remember, this 1 is going to donate its electron to that empty hole right there. So sodium is going to lose that electron, while chlorine will gain an electron. So this is not a new concept. We're just now putting a name to this type of reaction. If you are looking at the element that has lost electrons, that's known as oxidation. So in our example, sodium has lost electrons. It has gone through oxidation. In this case, my element does become positive, as we know, sodium is going to have a +1 charge. Those are things we've learned before. We're now just putting a name to it. We're saying that this thing has now been oxidized. It has become more positive. The other flip, the other side, chlorine. Chlorine did gain an electron. So when they gain an electron, they're going to become more negative because our electrons are negative. So in that case, we say that chlorine has been reduced. So here, our chlorine is going to have a -1 charge because we gained just 1 electron. So in this case, the reduction and oxidation work together. It's always a give and a take. One loses an electron, one gains an electron. If that happens, they have to work together. Electrons don't just get flown off into space when an element does not want them. They have to go somewhere. They're going to go to that other element. This type of reaction then, we take the words reduction and oxidation and squish them together to make this what we call a redox reaction. So a redox reaction is that one. So last thing then, you guys have the homework reinforcement section 3 worksheet to do. So please review this as many times as you need. Ask questions in class if there was anything that you did not understand. Have a wonderful afternoon. Bye-bye.